Okay, so the next thing we're going to talk about is something called extractions. And so you're going to see on an exam question, basically half your page taken up by a single question is going to look something like this, a spider web of reactions, and what the heck even goes on in here. So these questions really aren't that bad. They look scary, but they're just a bunch of rules. And once you know those rules, every single question is exactly the same. So the first thing to do is look at the molecules they give you at the start of the reaction series. Typically, they'll either give you 2 or 3. Now, the goal of an extraction is to take these things, mix them into a vial, shake up that vial, and things are going to get separated based on if they're acids, bases, whether they're polar or non-polar. Okay? So, the first thing to do is look at your molecules and ask the question, who is my most acidic structure? Who is my most basic structure, and who kind of falls in the middle? Who isn't the most acidic nor the most basic? So let's start by looking at this molecule right down here. Well, this is a functional group you should recognize. A C double bond O, OH, that is a carboxylic acid. And as the name implies, it's a pretty strong acid. So this is most likely our most acidic structure. And now we have a nitrogen, and when we talked about basicity, we said that nitrogens, especially nitrogens that aren't on double bonds, are pretty acidic, pretty basic. Nitrogens that aren't on double bonds are very basic. And so, I got some dry erase marker in my mouth. Oh, that tastes gross. Anyway, that nitrogen is fairly basic, so we know that this nitrogen is most likely going to be our base. And now, typically the structure that falls in the middle will be one of two. Either something that is just carbons and hydrogens, which generally aren't basic or acidic, they're fairly neutral, or amides. Amides we talked about before, which were the carbonyl that also has a nitrogen on it, like this. Let me draw this in a different color so it's easier to see. So, for example, that's not better. Double bond O with a nitrogen, and let's say there are 2 methyls. Typically, these guys aren't very good bases or acids, even though that nitrogen is there, and we said nitrogen is usually a base. Not such a great base when it's connected to a double bond O, because the nitrogen's lone pairs are in fact resonating, and they don't want to be given up for that reason. Okay? So that said, identify your base, your acid, and the thing that's in the middle. I'm going to refer to that thing in the middle as your neutral. So, colors, whatever, neutral. Okay? Once you have those 3 structures identified as what they are, you go to the first step. But you choose one of these molecules. Only react with one molecule at a time and ask where does it go. So let's start with the carboxylic acid. So we have a carboxylic acid, and now over the arrow we have NaOH. And remember, NaOH is a source of OH minus, a good base. So if you have a carboxylic acid in the presence of a good base, what is going to happen? That carboxylic acid will get deprotonated. So that OH minus grabs this proton on the OH and makes that O minus, and so at that point you have this. That's our step 1. Now our next step, we have to think about the solvent we're using. So the pathway splits. We have water and we have ether. Water is a good polar solvent, and so it likes to dissolve things that are polar. In other words, things that are charged. So if you have a structure that is plus or minus, it's going to dissolve in the water. On the other hand, ether is nonpolar. It likes things that are not charged. So if you get to a point here at the diverging arrows where your structure is neutral or uncharged, it dissolves in the ether. Well, based on what we figured out, since carboxylic acid is an acid and it gets deprotonated by a good base, it's going to go down the water route, because we're here, it's O minus, and plus or minus dissolve in water. So we're now here. Now, when that carboxylic acid got deprotonated, it became its conjugate base, right? An O minus. We're taking a conjugate base and now reacting that with HCl. HCl is a good acid. HCl, so H+, right? HCl gives you H+, an acid. So if you have a conjugate base and you're reacting it with an acid, what happens? The conjugate base gets protonated. And so this gets turned back into carboxylic acid. So now we go again to this chart. The carboxylic acid, as we drew it, is no longer charged. It is neutral. So where does it dissolve? In the ether layer. It dissolves into the ether because it does not have a charge. So we follow the arrow even further. The carboxylic acid would end up where B is. Okay? Let's do this again, but for a different structure. Let's do our base now, our amine. Okay, so the amine we said is a base. And our first step is to react it with OH-. Now, a base will generally not deprotonate another base, meaning what you get at the end of this reaction is still NH like that. Okay? In general, acids will not react with acids, bases will not react with bases. Since we have a base and we're reacting it with a base, nothing will change. So is this nitrogen plus or minus? No, it is neutral, which means it will dissolve down the ether route. But now we have a good base reacting with HCl, which we said is a good acid. Now something will happen because it's not a base reacting with a base, it's a base reacting with an acid. That nitrogen will get protonated by the acid and become NH2 plus. So where is that NH2 plus going to go? It's charged, so it's going to dissolve in the water. So it's going to go up like that. Okay? So again, just like we said here, we made a conjugate something. If you start with an acid and deprotonate it, it becomes a conjugate base. If you start with a base and protonate it, it becomes a conjugate acid. So we have a conjugate acid reacting with OH-, a base. Acid-base reaction, so this will get deprotonated and become NH neutral again. So where will this dissolve? Into the ether layer, because it is neutral. So your answer here, your amine will end up being in D. Okay? So now let's do the molecule that's in the middle, because that's actually the easiest of the bunch. The molecule in the middle can never get a charge because it's neither a good acid nor a good base, which means every single reaction, it will remain the same thing. This benzene does not react with OH-, so it stays benzene. Uncharged dissolves in ether. Benzene again is not a good base, so it won't react with the acid either. It remains uncharged and dissolves in the ether. So in general, your neutral molecule will just travel the ether route every step of the way. There are some technicalities to this, but generally I don't see them. So we know that the benzene should end up in E, because it will never end up getting a charge from either the acid or the base. Okay? But now I have a question, because while this doesn't come up often, it can still come up, so I want to mention it. What ends up in A and C? Because something actually does end up in A and C. Remember what your acid and your base are made of, meaning NaOH and HCl. In the NaOH, you're using the OH-, but that Na comes off as Na positive. So technically, when you make this conjugate base in that reaction, you have also produced Na positive. Where will that Na positive dissolve? Well, just like before, anything with charges will dissolve in the water. So that Na positive is going to go in the water route along with the conjugate base of your carboxylic acid. And in this step, HCl, we used the H+, but that left behind a Cl-. So now we have a Cl- floating around that will couple with the Na. But they stay as ions because it's an ionic bond. They're always going to be with their associated charges, Na positive, Cl-. So what ends up in A will end up being those ions, the Na positive and the Cl-. And it's the same deal for C. In the first step, you made, or in this step right here, you used the HCl, so you got left behind with Cl-. And that dissolves in the water. Then you used NaOH, you made Na positive. And so both the Cl- and the Na positive will wash out into choice C. So do they ask about this often? No. But on the off chance they do, here you are. One point to make is almost always, if you go complete, you do one, or Actually, I'm just going to cut the video here. That's the idea of extractions. Okay? So it's kind of convoluted, but the process is always the same. Start by deciding who's an acid, who's a base, who's in the middle. And now look at your arrow. If you have a base, it reacts with your acid. It does not react with your base. Okay? So, and then it's just a matter of checking your charges. If something is plus or minus, it goes down the water route. If it is not charged because it didn't react, or it reacted and became neutral, it goes down the ether route. And you just keep checking and checking until you go to the end and you run out of options. Okay? So that's the basic idea behind extractions.